This is the last video of Chapter 8. We're going to talk about solubilities. It basically tells you which compounds dissolve in water and which ones don't. And when a chemical reaction forms, which compounds will be precipitates, will be the solids in the reaction, which ones will stay dissolved. So on your yellow sheet, you have a data table that's full of S's and I's. The S on that data table, and I'll be pulling it up in a second here. The S stands for soluble, means that that compound dissolves in water, or that it's aqueous if it's put in water. The I stands for insoluble, which means it does not dissolve, which means that if it forms in a reaction that is in water, it will precipitate out as a solid. Or if you try to put it in water, it will not dissolve. So this is the data table I was referring to. So I means solid, S means aqueous. So that's kind of a little bit tricky when we do start labeling them. When you come across or when you write out your reactions and you decide whether your compound is a solid or aqueous, S will actually mean you write AQ, and an I means you write S, which is kind of weird. I'll show you some examples in class. We won't do that in this video. But solid ions, or soluble ions, are aqueous. We do have these things called spectator ions. So there's ions that, when we write a chemical reaction, if they remain aqueous at the start and at the end, they stay aqueous the whole time, they aren't actually reacting necessarily. So we call them spectator ions. They're not changing state. If they're dissolved before they react and after they react, they're not actually reacting. And that's a little bit above kind of where we're at. I can explain that in better detail in class. We're just going to leave it at that for now. They stay dissolved in water the whole time, so they're not truly reacting because they are just remaining dissolved in their as separate ions. So insoluble ions, they change in state. They typically go from aqueous to a solid, so we typically see them as precipitates. So that's the insoluble ions, so usually a precipitate. So what you need to be able to do for this class is decide whether each compound is soluble or insoluble in water. So this is kind of the bare bones of what you're going to do, and then we'll apply it and actually do a lab, potentially if we have time, where you do a bunch of double replacement reactions and you figure out what the precipitate in each of those reactions is. So we're going to start with PbCl2. If we look at our table here, here's what you got to do. All your cations are on this side. All the positive ions are on this side. All the negative ions and polyatomics are on the top. So what you got to look up is lead is my positive ion, chloride is my negative ion. So okay, chloride is right here. Now I've got to look up lead. Now there's only one option for lead. It's lead 2, which in this case, this one is a +2 charge, so that's the one we're looking at. Now what you do is you go across from lead and you go down from chlorine. So when lead and chlorine combine to form lead 2 chloride, that is a soluble compound. So we put AQ after it. So we put AQ there. And I'll erase that and bring the AQ back. Now for the next one, we've got Na2CO3. So Na is sodium, so I find sodium right here. And then I find carbonate. CO3 is carbonate, which is right here. So I go down, 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 right there. And I go right there. That one is also soluble, so I'm going to put AQ after that one as well. This one's AgI. So I'm going to have you actually take a second and do the last two examples on your own. Pause the video, and then I will come back and do them. Okay, so hopefully you had a chance to do those, see if you're correct or not. Let's go to silver iodide. We find silver is here, iodide is here, so we'll drop down from silver, and then we go over, and that one is insoluble, meaning it does not dissolve. So we put a little S because that one will be a solid in a reaction. That will precipitate out if it forms. If we're running a reaction in water, that will precipitate out as a solid. Now the last one, FeI2, we look, iron, there's two options for iron, iron 2 or iron 3. In this case, iodine has a -1 charge, so there's two negative ones. That means this iron must be a +2, so it is iron 2. Then I go iron 2, and then we've already got a line through iodine, so that one is soluble, so we put an AQ after that one. So make sure if it does have two options like mercury, tin, or iron, that you pick the correct oxidation state of the metal, because it will make a difference if we're looking at like mercury hydroxide. It will make a difference which one you pick, mercury 1 or mercury 2 there. So that's all we're going to do for that. Make sure you can read this table and apply this, and then we'll use it to solve for precipitates or determine what our precipitates are in chemical reactions.